On August 12, 2026, the moon's shadow will sweep across the Arctic, Greenland, Iceland, and northern Spain, turning day into night for up to 2 minutes and 18 seconds. Millions more across Europe, North America, and northwestern Africa will watch the sun partially disappear. Not because anything is wrong, but because the universe has, by pure chance, lined up two objects that should never match this perfectly. The sun is nearly 1.4 million kilometers across. The moon measures just 3,474 kilometers, roughly 400 times smaller, but the sun also happens to sit about 400 times farther from us than the moon does. The result? In our sky, the two appear almost exactly the same size. It's a coincidence no other known planet in the solar system shares. A natural satellite matched this precisely to its star. If the moon orbits Earth once a month, why don't we get an eclipse every single new moon? The answer: the moon's orbit is tilted roughly 5 degrees relative to the plane in which Earth moves around the sun. Most of the time, the moon's shadow passes above or below the Earth entirely. Only about twice a year, when everything lines up perfectly, does that shadow actually touch the planet's surface. When the alignment is perfect, the moon's shadow has two parts: the penumbra, a wide area where the sun is only partially blocked, and the umbra, a narrow cone of complete darkness, only a few hundred kilometers wide. Only those standing exactly inside that cone see a total eclipse. Everyone else, if they're lucky, sees only a partial one. The shadow will first touch down in the far north of Siberia, near the North Pole. It will then cross the Arctic Ocean, Greenland, and the west coast of Iceland, passing near Reykjavik, before sweeping into northern Spain and finally a small corner of Portugal. This will be the first total eclipse visible from Iceland since 1954, and the first total eclipse over mainland Europe since 1999. At its longest, totality will last 2 minutes and 18 seconds over the ocean just off Iceland's coast. Nearly an hour before totality, the moon begins to take a bite out of the sun's disk. Gradually, the light weakens, shadows sharpen, and the temperature drops noticeably. Seconds before totality, the last rays of sunlight pass through valleys along the moon's edge, creating what's known as Bailey's beads. Then, one last bright point remains visible, the diamond ring effect, just before the sun disappears completely. For those 2 minutes and 18 seconds of totality, the sky darkens enough to reveal stars and planets in the middle of the day. The sun's corona becomes visible, its outer atmosphere reaching temperatures beyond 1,000,000 degrees, normally hidden by the glare of the solar disk. The air temperature drops by several degrees. Along the horizon, in every direction, an orange glow appears, like a 360-degree sunset. Animals react as though night has fallen. The last total eclipse visible from mainland Europe was in 1999. The next one, after 2026, won't happen until 2075. If you live in Europe and miss this moment, you may never get another chance. That's what makes those 2 minutes on August 12th one of the rarest shows the sky has to offer. One essential thing to remember: the only moment you can look at the sun without special glasses is during totality itself. At every other phase, certified ISO 12312-2, eclipse glasses are mandatory. The rest of the time, the sun remains strong enough to damage your eyes, even though it looks much dimmer to the naked eye.